All right, we are diving into 9.1 where we are looking at trig identities and specifically the ones in green here we've seen before. So we have the reciprocal identities and quotient identities as you see here. And don't let the theta fool you. You could change that for x, and you'll see that in here or whatever. We also, I think, beta is used as well. So don't let that variable scare you or think that something has changed. It's just another variable. And most of the time you'll see theta, as you see kind of the circle with the little line through it. But a lot of times you'll see x used most of the time. The ones that we use, we've seen this before as well. We have sine squared theta plus cosine squared theta is equal to 1. And we'll see variations of that. So we could subtract the sine squared x, and you would get cosine squared is equal to 1 minus sine squared x. So we're actually just going to be moving these things around. And then in order to get these other two, the 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. And we could basically, all we have to do in this original Pythagorean identity is simply divide. If we divide by cosine squared on everything, sine squared over cosine squared, as you can see here, becomes tangent squared. So that's where this comes in. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. So in order to derive these other ones, we're simply just dividing either by cosine squared to get this one, or we're dividing by sine squared to get this one here. And then here we're looking at even and odd identities, and this is an old thing that we've looked at, and this is nothing more than we change the value of x to its negative or vice versa, and we get a positive y. Or if it's an odd function, as you can see, most of them are odd, circled in red. Is when we change the x value and we get a negative y value. So that the only even functions are cosine and its reciprocal secant. And we have a couple of those questions here, and it's very straightforward. So is tangent odd or even? Is cosine odd or even? So if you can just remember cosine and its inverse secant are the only even functions, then you know the rest are odd. And so then we play this out. So cosine, since it is an even function, that means I'm going to end up here as we have a positive y value. All right, and then we have an odd value here. So that odd value means that the y is negative. So that's all we're playing at here. Nothing is happening. We're not evaluating anything. We're just saying, oh, this is an even function. This is what should happen to the y value. This is an odd function. This is what should happen to the y value. So that's the only thing happening here. Here we're not doing anything with the 3 pi over 2. Simply cotangent is an odd function. We should have a negative y value, and that's it. And so for the rest of these, we're going to start looking at the identities, and then we're trying to simplify them in a sense. So we can rewrite, so if we look at 1 over secant, if we kind of separate these two and look at it as cosecant times 1 over secant is cosine of x. And then if we look at cosecant, that's the same thing as 1 over sine of x. So now we can change this problem to being cosine times 1 over sine of x, and that is another way of writing cotangent. So there's no real one way of doing these things. We just kind of have to try and simplify it by just looking at those identities. Here we have cotangent. So this is an odd function, so we should have a negative y value. And then here, another way of writing secant is 1 over cosine. And so now we can change this as to 1 over cosine times cosine, which is equal to cosine over cosine, which simplifies to 1. And here we're seeing beta being used as the variable, no big thing here. 1 over cotangent is tangent, so now we can see this as tangent times tangent, which gives us tangent squared of beta. Here we're looking at the Pythagorean identities here, and so it's that original one of 1 plus tangent squared is equal to secant squared. And if we subtract secant and if we subtract tangent, this is what we end up with. So we can see this statement here is equal to negative tangent squared of x. Here we can rewrite this statement as cotangent squared of x, and then secant, as we saw in the one above, is another way of writing 1 over cosine. So this gives us 1, and so we can look at the original Pythagorean theorem identities, and we can see that cotangent squared plus 1 is equal to cosecant squared of x. And if you need to refer back to these, have those ready and available for yourselves. And then here we can rewrite secant again as cosine, and we end up with 1. Here, this is another way of looking at the Pythagorean identity, and we're just simply subtracting that cosine of x so that it equals sine squared of x. Always watch out for your variable because it might change. Like here, it now becomes t. So if you put cotangent squared of x there, it would mark it wrong. As you see, I wrote it here, but I watched out for it there. Here we need to distribute, so we're multiplying times reciprocal, so that should give us 1. Since cosine squared is negative, that becomes -1. And then we're multiplying times here, so it gives us positive. So this is just another form of the Pythagorean identity. We've just moved things around, and that gives us our answer here of negative sine squared of x. And then looking at here, let's move this over here so we can see a little bit of this. Just looking at some of these notes here. And so we need to FOIL this, and so that's where we end up with the 1 plus cotangent minus tangent minus 1. So the 1's cancel, leaving us with this. And the only thing we really need to look at here is a reminder that cotangent is 1 over tangent. And that's how we end up with that -1 on the last part. And this last part here, we are multiplying. So cosine times secant, which is 1 over cosine, gives us 1. 1 times cosine gives us cosine squared. So we end up with 1 minus cosine squared, which is another variation of the Pythagorean identity.